Hello.
Can you see the screen? What happened?
Sorry.
Okay. So in the last lecture, we did the boiling points, right? Yes or no?
Yes.
Okay. Now let us write about melting point. Now in melting point, you will only see one question that is very important. And let me write that in the form of question only. So please write. P dichloro benzene has higher melting point than its ortho and para isomer.
So ortho and meta.
Sorry, ortho and meta. Correct. Ortho and meta isomers. Explain. So if we look at the structures of ortho and meta isomers, we can see that para isomer will have chlorine here and a chlorine here. Ortho will have a chlorine here and a chlorine here, right? And then meta will have chlorine here and a chlorine here, right? So when we look at the structures of para, ortho, and meta isomers of dichlorobenzene, what do we see? We see that the para isomer is what? It is symmetric. Yes or no? Can you see that? Zen?
Yes, yes.
So if something is symmetric, in melting point, there are two things. Melting point will be directly proportional to the intermolecular forces of attraction. That is very true. That is right. Okay. But melting point also depends on the packing efficiency, or how efficiently is the crystal it is packed. If it is packed very efficiently, then what will be happening? Breaking it will be very difficult. Okay. And since this is symmetrical, the packing of this p dichlorobenzene will be easier. Is that clear? Yes or no? Please tell me.
It's a Q.
Okay, fine. So yeah, what will we write here? Tell me.
So like para will be more symmetric. So
It
it
has due to
uh,
symmetrical structure, right?
yeah,
So we'll write p dichloro benzene has higher melting point than other isomers. That is ortho and meta ones. Okay, due to symmetrical structure. Then further you will write due to symmetry. Due to symmetry, atoms of p dichlorobenzene can easily fit in their crystal lattice and form closely packed structure.
okay.
Just wait a second. Let me share this.
So finished.
Now, write one more point, that is dipole moment. In dipole moment, you will write the dipole moment of haloalkane is more than the dipole moment of haloarine. Okay, it is more than haloarine. Why it is that? Why it is the case? Because let us see if I have. Let us take a similar structure. Haloarine is a benzene that is connected with a halogen atom like this, right? And haloalkane, let us take cyclohexyl chloride or cyclohexyl halide. Now, here you can see that this particular bond here, it will have a partial double bond character. Is that right? Yes or no? Please tell me.
Yes.
Because of resonance, it is having partial double bond character. Now, if there will be partial double bond, then we know that double bond is shorter than single bond. Correct? Yes or no?
Yes.
Double bond has its shortening. And what is the formula for mu? Tell me. What is the formula for dipole moment? It is equal to फिजिक्स में पढ़ा होगा ना डाइपोल मोमेंट. बताइए.
I don't remember.
Q into D. Right?
Still don't remember. Okay.
You don't remember? Okay. So mu is equal to Q into D, where Q is what? Q is the charge. And D is the separation. Okay. So distance of separation. So this is distance. Now, as you can see, the first thing is that if the single bond is what? It is longer, that means its dipole moment will be higher. Is that right? Yes or no? Please tell me.
Yes.
Okay. Next point is also, this is what? This is sp3 carbon. And this one here is sp2 carbon, right? This is here sp2 carbon. And sp3 carbon is what? It is less electronegative than sp2 carbon. So the electronegativity difference between sp2 carbon and halogen will be what? It will be lower. That means both the things are lower here. That means the charge is also lower and the distance is also lower. That is why what is happening? Dipole moment of haloalkane is more than that of haloarine. Okay. So
yes.
let us write here. Okay, please write. Since it is CX bond in haloarine has double bond character due to resonance. The bond length of CX bond is shorter than that of haloalkane. Then you write furthermore, the electronegativity difference, electronegativity between sp2 carbon and halogen is less than sp3 carbon X of haloalkene the electronegativity difference between the sp2 carbon X bond is less than sp3 carbon of haloalkene. Therefore, the magnitude of dipole moment, which is mu is equal to q into d in haloarine becomes low.
Okay.
So, right.
So finished.
Missed.
Yes.
Now, right. Solubility, no? Solubility. Haloalkanes and haloarenes are polar, but still not soluble in water. Since they can't form, hydrogen bond, neither they can break the hydrogen bonding of water. Okay, and that is why these are not soluble. No? So haloalkane haloarenes are polar but still not soluble in water. Please write this down. Let me know when you're done.
Okay. So finished.
Done. Okay.
Yes.
Now write the topic. Let us understand there is one type of reaction which is known as nucleophilic substitution reaction. So let us understand that reaction. Then we will look at the types of reaction. We'll look at the mechanism first. What happens in general? So please write nucleophilic. Substitution reactions. Nucleophilic substitution reaction. So what is nucleophilic substitution reaction? Let us write the definition. The reaction in which group, and in this case what will be there? Halide will be there. Okay, so in our chapter halide will be there. A reaction in which group of the substrate that is reactant is replaced by a nucleophile is called as a nucleophilic substitution reaction. They are written in shorthand as SN. Okay, so it's called nucleophilic substitution. Okay. Now
Yes.
in general what we can write, Rx plus there will be a nucleophile, and this nucleophile will attack on this, and then what will happen? X will be removed. So you will get a bond like this, RNA plus X negative. Okay. So let us write the simple things, what is happening in this reaction, which type of bond is breaking and what is happening. Please write. In SN, that is nucleophilic substitution, one base is replaced by another base. Now, when I say base, I mean electron rich species. Okay, electron rich species. Base means electron rich. Base has a high concentration of electron. है ना? OH negative जो होता है क्या होता है ना? So in general, the most general base you can say is OH negative. But anything which is having a very high concentration of electron, in which the electron is very high, that is a base. In SN, one base is replaced by another base. Please write the next line. The incoming base, the new base that is coming, is called nucleophile, and the outgoing base is called, leaving group. Leaving group.
Yes.
Okay, it is known as leaving group. Now, nucleophile can replace this X only if the nucleophile is stronger. Is that right? Yes or no? Please tell me.
Yes.
So he is going to someone's home and he's kicking them out. That means it should be stronger than the incoming. So you should say, sorry, the incoming base should be stronger than the outgoing base. That means the nucleophile should be stronger than the leaving group. Correct? Yes or no?
Yes.
We'll write for the feasibility. Feasibility means for the reaction to happen, of this reaction, incoming base should be stronger than outgoing base, that is the nucleophile. Stronger than outgoing base, or we should say that outgoing base should be weaker. Now, next point is, oh, wait a second, write it like this. Should be stronger, and the outgoing base should be weaker. Okay, right, next point. The most important point is two things happen. In SN, right? Number one is the cleavage of CX bond. Number two is what? Formation of carbon and nucleophile bond. Okay, so only two things are happening. Now, these two things can happen in single step also, or they can happen in one step also. Okay, so we'll look at that first. Please write this down. Let me know when you're done.
So then.
Done. Okay. Now see types of SN. Okay, types of SN. So there are two types of SN. We will write first. So समझ लेते पहले. Please don't write this. Okay, don't write this. Now, okay. SN in double step, let us say in two steps, or SN can happen in single step. SN in single step. Okay, SN in single step. Now, if SN is happening in two steps, that means let us say Rx. First step will be Rx. This bond will cleave and it will form a carbocation R positive. Then the second step, what will happen? R positive will be attacked by the nucleophile and it will get Rn.
Carbocation formation here.
R plus is carbocation. Rnu. Correct? Now, if it is happening in single step, then the single step will be something like this. Rx plus nucleophile. In this step, what happens? The nucleophile attacks on the R and then the X leaves the single step. And you will be forming R. So here you get X negative. Rnu plus X negative. Clear? Yes or no, please tell me?
Yes, sir.
Now, the most important thing is the rate of reaction. What? The rate of reaction, how fast a reaction will happen. Rate of reaction, it depends on which step. In this step or this step, depends on which step. So I will ask you a simple question. Let us suppose you are drying 3 clothes, okay? 3 items of clothes. One is t-shirt. It takes 10 minutes. Second is shirt. It takes 15 minutes. And let us say you have the third item, which is jeans. That is 13 minutes. Now you tell me how much time will be taking in total to dry all of these 3? कितना टाइम लगेगा अगर आपने सुखाया इन तीनों को तो? Yes, sir.
So 55 minutes.
Okay, so you have washed them all, right, Zed?
Yeah.
Okay. Then you went to dry them all.
Okay.
ठीक है?
Yeah.
अब बताइए कितना टाइम लगेगा?
I don't. Okay.
55 only?
I think double हो जाएगा टाइम.
डबल हो जाएगा टाइम? नहीं, सिर्फ आपको सुखाने में कितना टाइम लगेगा?
सुखाने में यहाँ पे ड्राइंग का लिखा है तो ऐड ही करूंगा तो 55 ही हो रहा है.
नहीं, फिर से समझते हैं ना, रियल लाइफ में आप याद करके ऐसे आप तो जोड़ ले रहे, मैथ्स हो जा रहा है. बट थिंक ना, यू वेंट, है ना, यू हैड टी शर्ट लगा दिया आपने, शर्ट को लगा दिया आपने, जीन्स को भी लगा दिया आपने.
ओके.
कितना टाइम लगेगा? अरे 30 मिनट में तो सारे हो जाएंगे ना, जब तक जीन्स सूखेगा, टी शर्ट और शर्ट.
सॉरी क्या if you place all them together.
No. If them क्या मतलब, you will always place them together only, right?
सही बात.
You are not waiting, correct? So
जी.
similarly here also, see, the jeans is the slowest step, right? Yes or no?
Yes.
The slowest. Acha, when I say slow, when I say these are 2 steps, it doesn't mean that first will happen only then the second will happen. ऐसा नहीं होगा. That let us suppose how many molecules of Rx we are taking. We are taking 6 into 10 to the power 23. How many we have taken? 1 mole we have taken, yes or no?
Yes.
Now, if any one of the molecules will do this first step, it is ready to do the second step. We are not waiting, right?
Yes.
Similarly, here also we are not waiting anything, correct? So here also the rate determining step, the step which is going to determine the time taken for reaction. What step? The time taken. So the time taken, the rate of reaction is what it is telling me, that it will be directly proportional to, or it will depend on the slowest step. So rate of reaction, let us write one line here like this in some respected space. Now, since we have not done chemical kinetics, that is why I have to write this very clearly. Rate of reaction depends on slowest step. Okay, it depends on what? It depends on slowest step. Is this clear? Yes or no? Please tell me.
Yes.
Okay. Now, what do you think? Step 1 or step 2, which will be slowest?
So step 1.
Why?
So because nucleophile is forming and it is reversible, so maybe no. Their bond cleavage is bond is breaking, so maybe it will be longest step.
Why? What happens in bond breaking? What do you think?
As carbocation is more stable, so it will take more time to break.
नहीं stable की बात नहीं. No, it's
Okay.
not that. See, the reactant and the product. So reactant is what? Neutral,
Yes.
correct? And product is charged, correct?
Yeah.
Now you tell me, neutral is more stable or charged is more stable?
I think neutral. Yeah, neutral is more stable.
Neutral is more stable, right? Now we are going from something which is stable to unstable, then obviously it is going to take more energy and as well as that more time also, correct? Because we are
Yes.
breaking a bond. Correct? That is why it takes more time. But if I look at the second reaction, it is kind of an acid base which is very fast reaction. Here we have positive charge, and then in nucleophile you will either have a negative charge, but there will be obviously a lone pair electron will be there. So electron is negatively charged and positive charge, they are reactive, positive and negative, so it is going to be very fast. As soon as it will form a carbocation, this second step will happen. Okay, the second step will happen, and that is why we can say that it depends on here rate determining step. RDS is what? Formation of carbocation. Now the formation of carbocation, it has only one reactant, and hence the rate will depend on the concentration of Rx, only one molecule. And since it is depending only on one molecule, it is also known as
First order kinetics.
first order kinetics and unimolecular nucleophilic substitution. And written as SN1. Okay. And here, as you can see, we have only single step. That means the RDS will be the first step only. So here you can see that there are two reactants, and hence the rate will depend on the concentration of Rx, that is the substrate, as well as the nucleophile, and that is why it is known as bimolecular nucleophilic substitution, and it is known as SN2. So we will be learning about two types of nucleophilic substitution, SN1 and SN2. Okay, so you have understood this. Now let us write about this. Okay, can we start writing?
Yes.
Please write. First is SN1, unimolecular nucleophilic substitution. Okay, now the reaction in which rate depends on concentration of only substrate, and here alkyl halide. Okay, the reaction in which the rate depends only on the concentration of substrate is called unimolecular nucleophilic substitution. Now for this, the rate law will be R is equal to the rate constant K into the concentration of, let me write it like this, substrate. But in this reaction, in this chapter, we'll write this as K, and what is the alkyl, or that is Rx. This is our substrate. Okay, fine.
Yes.
Then you will write order of reaction. Will be equal to 1. This is very important, that the order is 1, and molecularity is also equal to 1. Both is equal to 1. After this, write the mechanism. Please write in mechanism. It happens in two steps. The first step is what? Cleavage of CX bond. This step is also known as formation of carbocation. Okay, so a carbon atom will be there. It will be bonded with three other groups or atoms and X, that is halogen. And you will be using a polar solvent. We'll understand why polar solvent is used. This step is reversible also, and this step is slow also. Okay, the polar solvent will be there, and you will be forming carbon plus X negative. Now, since X negative is here, there is a high probability that it can attack this carbocation and can again form the alkyl halide. Okay. Take the next step. Formation of carbon nucleophile bond. You can also call this step as attack of nucleophile. Now here what will happen? You will have the carbon, carbocation plus a nucleophile. This nucleophile will obviously be containing a lone pair. So negative charge is optional. It can contain and not contain also, but it is going to be having a lone pair electron, and you will get carbon, 3 bonds and a nucleophile. Okay.
Yes.
So this is very fast. It's fast reaction.
So is nucleophile still having like a negative sign at the last?
Here.
जी.
No, product में तो negative sign नहीं होगा ना, तो bond बना लिया उसने. कुछ नहीं होगा. Bond है ये. This is not a negative sign. This is just a bond.
Okay. So finished.
Yes. So let me copy this. And then you write the topic bimolecular.
So I wanted to ask like यहाँ पे जो polar solvent use कर रहे हो aprotic है aprotic?
It is what is aprotic and protic? Tell me that.
So aprotic examples are what I'll call ये मतलब aprotic हो जाएंगे जिनमें मतलब जो positive sign जो proton क्या बोलते हैं
आएगा ना, जब वो पार्ट आएगा तो पता नहीं. ठीक है.
Yeah.
अभी आपको प्रोटिक एप्रोटिक का फर्क नहीं पता, तभी छोड़ देते हैं उसको. राइट. So when we will be discussing the factors affecting nucleophilic substitution, then we will discuss that. ठीक है. चलिए. This is what bimolecular. Bimolecular nucleophilic substitution. Now, please write the reaction in which आपको प्रोटिक एप्रोटिक में डिफरेंस याद आता है जो बताइएगा, हम आपको बता देंगे कौन सा यूज होगा. ठीक है. You try to remember that. Okay. The reaction in which the rate depends upon the concentration of alkyl halide, that is a substrate, as well as the nucleophile. As well as the nucleophile spawned SN2. For this reaction, the rate law is R is equal to the rate constant K multiplied by the substrate concentration into the concentration of nucleophile. In this chapter, you'll write this as R is equal to K into concentration of alkyl halide into the concentration of nucleophile. Okay. Now, what is the order of reaction?
Second order.
2. Order of reaction is equal to 2. And molecularity is also equal to. Now let us write the mechanism. The cleavage and of CX bond and formation of CNU bond takes place simultaneously. Simultaneously. We have carbon X bond like this. Okay. Draw this as so nucleophile will attack here and this bond will break, leading to formation of, wait a second, leading to the formation of a transition state. You're having nucleophile just forming bond with carbon, and this bond is breaking with halogen, and the 3 groups are attached like this. Okay, so rather let me write this as red, showing that it is going to break, and this is blue, it is going to form. Further on, what happens? We see that nucleophile is attached on the carbon on the opposite side to that of the halogen atom. So I'll explain about the stereochemistry later on, but right now write the mechanism like this. No, right? Factors affecting SN1 and SN2. There are 3 factors that is going to affect the rate of SN1 and the rate of SN2. The first one is nature of substrate. What is the substrate here? It is alkyl halide. It is alkyl halide. Second is nature of leaving group. The third is the effect of solvent. Okay. So first of all, we'll discuss the nature of substrate, that is alkyl halide, then the nature of leaving group, and then the effect of solvent. Chaliye. Let us write the first point, nature of substrate. In nature of substrate, first of all, we'll look at the reactivity of SN1. Reactivity of SN1. Please write reactivity of SN1. Is directly proportional to the stability of carbocation. Directly proportional to stability of carbocation. That means we can also say that. And what is the order of stability of carbocation? More substituted carbocation is more stable. That means rate of SN1. If all the halogens are same, then the methyl halide will have the slowest, followed by 1 degree, followed by 2 degree, and followed by 3 degree. Okay, so write this down. Why is this? This is the rate of SN1 because stability of CS3 positive is less than CS3CH2 positive is less than CS3CH CS3 positive, and it is also less than CS3 whole thrice is attached to carbon positive. Okay, write this down. Let me know when you're done. This is 0 degree, 1 degree, 2 degree carbocation, and 3 degree carbocation.
Okay.
Okay. Now, write the reactivity of SN2. Reactivity of SN2. It depends on the nature of bulky group attached at the alpha carbon. Okay, so what is the alpha carbon? Alpha carbon is what? It is the carbon attached to carbon of CX bond. Okay, so this carbon is what? It is known as the alpha carbon. It is known as the alpha carbon. As the number of alkyl group increases, what is going to happen? Increases at alpha carbon. As the number of alkyl group increases at alpha carbon, what is going to happen? It will hinder the incoming nucleophile due to which the activity of SN2 decreases. Hence, the reactivity of SN2 will be just the opposite of that of SN1. So CH3X, it has only halogen and there is no bulky group. It only has hydrogens, right, on the alpha carbon and no bulky group. That is why it is going to be highest, followed by CH3, CH2X, followed by CH3, CH3X, then followed by CH3 carbon, CH3, CH3X. Okay, so 0 degree is going to be more stable. Then what? Sorry, 0 degree is going to be fastest, followed by 1 degree, 2 degree, and 3 degree. This is also what? This is the rate of SN2. Please write this down. Let me know when you're done.
So done.
Now, for example, if you have something like this, comment on the reactivity of, comment on the reactivity of SN1 and SN2 in following.
Okay.
So we have CH2, double bond CH, followed by halogen. Okay. So if you have something like this, then what is going to happen? There are lone pairs here, right?
Yes.
There will be resonance, right? And
Yes.
since there will be resonance, due to resonance, what will happen?
It will be more stable.
This CH bond, due to resonance, CX bond will have partial double bond character and tough to break. Okay, and tough to break. Next point. Due to presence of pi bond, the nucleophile will be repelled. Okay, that means now there's one point which is very important that we have to just remember that one line.
We're finished.
So see, the same case will be also there if you have a benzene ring. If there's a haloarine, and that is why what will happen. Haloarine, they will not show SN1 or SN2. They will not show any kind of nucleophilic substitution. Okay, so these are the two reactions. These are the 2 points, and alpha unsaturation decreases the reactivity of both SN1 and SN2. Is that clear, Sandeep?
Yes.
Nature of leaving group. Okay. Okay. So right here, nature of leaving group. Reactivity of both SN1, SN2 increases if the Lg, that is leaving group, is stable and can bear charge. Okay, so if we look at the leaving groups, so leaving groups will be what? Fluorine, bromine, and iodine, right? So F negative, Cl negative, Br negative, and I negative. Now here we can say that since I is larger in size, it can easily bear negative charge and be stable. Okay, so you're right. I negative is a good leaving group. Right. Order of nucleophilic substitution. Okay. So it doesn't matter whether it is SN1 or SN2. Ri is going to be fastest, followed by RBr, followed by RCl, and followed by RF. So RF is going to be the slowest. Okay. Write this down. Let me know when you're done.
Certain.
Done. Okay. Write some questions. Compare the rate of following. Okay. So in the first question, what you have to, the first question. So in all of these questions, you have to compare the rates only. Okay. In all, you have to compare what? You have to compare the rates only. Now we'll compare number one. CH3, CH2, Br versus CH2 double bond, CHBr. Okay, so here you will compare the SN1. SN2 यहाँ पे कीजिए, SN2 कीजिए यहाँ पे. Then do something like this. You have here the same chlorine versus chlorine here. Here you will compare for SN, say what? SN1. Furthermore, compare CH3, Br versus CH3, I. Here you will compare SN2 and you will compare SN1. Actually, 4 सवाल कीजिए. So all of these are A, all of these are B. Okay, so which will be higher? You have to just, you can write in chat also A, B, C, A, B, A, ऐसे करके कुछ लिख दीजिए आप chat पे. Okay.
Oops. So rate means like
Which will be faster.
Which reaction will be faster? Okay.
Which will be faster.
So sorry, let me send again.
So you have sent for all of them B.
So I was confused in second one. Still confused. Yeah, बाकी सब पे तो V लग रहा है. Yeah. Okay.
पहले जो आपने आंसर किया था, व्हाट इज योर, आई वांट टू आस्क व्हाट इज योर थॉट्स बाय द वे, ऐसे आपने आंसर कैसे किया बताइए तो जरा.
Sir, for
फर्स्ट वाले
SN2, I thought like double bonding will be more preferable as.
व्हाई आप ध्यान तो बिल्कुल नहीं दे रहे यानी कि क्लास में, है ना जैन?
Sorry, double bond तो easily नहीं टूटेगा. Sir, I was confused.
डबल बॉन्ड इजीली नहीं टूटेगा, ये क्या बात कर रहे हैं आप? विच बॉन्ड विल ब्रेक, टेल मी ना. दिस बॉन्ड विल ब्रेक या दिस बॉन्ड विल ब्रेक?
So
कौन सा बॉन्ड ब्रेक?
CHBR, second one, second.
तो यहाँ पे तो डबल बॉन्ड नहीं है,
No, sir.
तो फिर क्यों आप बोल रहे हैं डबल बॉन्ड?
Sorry.
नहीं, लेकिन ध्यान आपका क्लास में नहीं है बिल्कुल. हम ज्यादा एक बात तो साफ बता दे सकते हैं, क्योंकि यहीं पे हमने बस लिखा है ना, comment on the reactivity. I
Yes.
have told that here if you get some type anything like this, then there will be a partial double bond, and that is why what will happen, the reactivity will be lower, right? Due to
Yes.
the resonance CH bond will have partial double bond character and tough to break, and due to presence of pi bond the nucleophile will be repelled. And then what I write, alpha unsaturation. Alpha unsaturation means what? The carbon with X bond, if it is unsaturated, if this carbon is unsaturated, means if it has a double bond or triple bond, it will decreases the reactivity of both SN1 and SN2. Alpha unsaturation. देखिए फर्स्ट सवाल में क्या है? Does this carbon has a double bond? Yes or no? Tell me.
Yes.
So it will be slower. This will be faster. Here this carbon, it is having double bond. Yes or no? Please tell me.
Yes.
So this will be faster. It is obviously it
So
is
first I
not
sent
only.
the same answer. Like.
वो हम नहीं पूछ रहे, वो हम वो बात ही नहीं कर रहे. उसके बाद तो आपने गलत आंसर भेजा ना.
Yeah.
आप उस चीज को ध्यान रखिए ना. आपका इसका मतलब तुक्का मार रहे हैं या तो आप. For the rest of the case, SN this will be faster, and then I will be faster because I is a good leaving group, okay, and Br and fluorine is not a good leaving group.
Yeah.
They are okay leaving group, but not as good as I. Is that clear? Yes or no? Please tell me.
Yes.
So I just, as I said in the last class, so today will be test for half an hour. Let me share the paper with you. So please write this down. Let me know when you're done. You have 30 minutes, okay? Ten marks is maximum. 3 plus 2 plus 1, 6 plus 4.
Recording in progress.
So Zad, if you have any doubt, just let me know. Okay.
Okay.
Hello, Hanifa. How are you?
Yes, sir. I'm fine. How are you?
Okay, wait a second. Ah, no, so you're fine.
Yes, sir. I'm fine.
Okay. So you came so late. The class is over. और आप कल भी नहीं आए थे. What happened yesterday?
Yesterday, I had an exam today, so I had to learn from that, and like I had to go to the dentist today. That's why I'm late.
So I know why you are late today, but see, never miss a class because of test and all. Okay. Like it is just 1.5 hour class. So manage your time. I will say that. You may have to prepare, but manage your time. Sleep 1.5 hour less. That is fine for one day, but don't miss the lectures. And also see, Saturday, Sunday, in the Saturday, Sunday batch, the case is that yesterday's lecture will be uploaded somewhere today. So you can't even watch that lecture. And it doesn't get uploaded as soon as it gets recorded. And I don't think you must have got the lecture also, right?
Yes, sir.
So what will you do now? What I will do now is I will share you the link of yesterday's lecture. You watch that lecture today. Okay? Will that be fine? Tell me.
Yes, sir. Yes,
Okay.
sir.
So fetch that lecture and send it to you.
Okay.
What was yesterday's date? Tell me.
25th.
25th, 06. And Zad, when you are done, you just send that, make a PDF and send it to me.
Okay.
Will that work?
Yes.
Okay. So D batch. Okay. You got the link, Hanifa? Yes or no? Tell me.
Yes, sir. I got it.
Okay, fine. चलिए. ठीक है then. Okay. So we'll meet on next Saturday. Yeah. And also what you can do is, can you see the title? If you see the title of that lecture now, then you will see that it is Learnivio Chemistry Lecture 12th MED. है ना? This is
Yeah.
lecture for 12th MED and this date. Then you will get the same type of title for today's, that the only change will be in the date, that is 26. So you can easily search on YouTube and get that lecture. Got it?
Yes.
Okay, fine. Achha, do you have any doubts on the previous lectures? Tell me.
No, sir. No.
Not right
I-
now. Okay, fine.
Yeah.
Also, is your chemistry test done?
Yes, sir. It was done last Thursday.
Okay, so any doubt in that?
No, we had like direct questions from the test book, so there was nothing like twisted up.
Wow.
So.
Okay, fine. Can you send the question paper to me? You have my number, right?
Yes, I do. Should I send it now?
Send it now.
Okay.
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 Okay, fine.
Just give me
Then we'll meet on.
time.
No problem. Okay. Fine.
Okay.
Bye. Take care.
Thank you, sir.
Thank you.
Zab, you have 6 more minutes. Okay.
Okay.